Today we're looking at section 2.8, solving absolute value equations and inequalities. If you remember inequalities, greater than, equal to, less than, equal to. Those are all inequalities. 4 vocabulary words, a compound statement, a disjunction, a conjunction, and absolute value. A compound statement is made up of more than one equation or inequality. Think compound, things that are put together, more than one thing that's put together. A compound statement, you can have a disjunction or a conjunction. First we're going to do disjunctions. Okay, a disjunction is a compound statement that uses the word or. Okay, disjunction, they're not connected. An example of a disjunction or a compound statement that uses the word or is on this number line. This is x is less than or equal to -1, or x is greater than 2. This is a disjunction, a compound statement that uses or. A disjunction is true if and only if at least one of its parts is true. Okay, your solution could fall within this part of the solution or this part. Okay, it does not have to be a part of both shaded areas. Your solution has to be one or the other. On the flip side of that, a conjunction is a compound statement that uses the word and. Conjunction is a compound statement that uses the word and. So here we have a number line and some shaded areas. Your conjunction here is x is greater than or equal to -1 and x is less than 3. Okay, the correct way that we're going to write this is the number first. Okay, this is your conjunction statement. Okay, 1 is less than x is less than 3. Or x is greater than 1, x is less than 3. A conjunction is true if and only if all of its parts are true. Okay, your solution has to fall within both of these statements for it to be a part of the solution. Okay, both. All of its parts have to be true. Okay, example 1, solving compound inequalities. Solve the compound inequality, then graph the solution set. This is the problem. It's really two problems written as one. Okay, we're going to solve it and then graph. Okay, divide both sides by 6. Y is less than -4. Or, opposite of add is subtract. Y is greater than or equal to -2. -5, 4. Okay, an open dot at 4. Arrow going this way. Closed dot at 2, arrow going this way. There is your answer. Okay, I'll circle it to make sure you know what we're looking for. This with the or in between, and this is your answer. Okay, solve the compound inequality, then graph the solution set. Here we have an and statement. So you're really solving two equations, and you're assuming that when you graph them, it's going to be a connected graph. So to solve this, multiply by the reciprocal. Okay, those cancel out. I'm left with c greater than or equal to -2 times 2 is -4. Subtract 1 from both sides. 2c less than 0. c is less than 0. Okay, open dot at 0, arrow pointing this way, close dot at -4. Hold on, so if I actually graphed this first one, I would be going all the way over. So the solution of c is less than 0 is open dot at 0, arrow going all the way to the left. The solution of c is greater than or equal to -4 is a closed dot at 4, arrow going this way. But we know that this is an and statement, so we've learned that your solution has to satisfy both c is greater than or equal to -4 and c is less than 0. So our actual solution is where they overlap. Okay, so blue is your answer. And then we would write -4 less than or equal to c less than 0. Okay, you have to put them together and graph them correctly. Solve the compound inequality, then graph. We have another OR statement. Add 5 to both sides. You're left with x less than 3. Or divide both sides by -2. What do you do when you divide by negatives? Right, switch the inequality. Okay, let's graph it. Open dot at 3, arrow going this way, close dot at 5, arrow going this way. So your solution is that and this. Okay, here's a problem for you. Solve the compound inequality, then graph the solution set. Go ahead and push pause and try it. Okay, we have your answer. Solved for x and graphed it. Okay, now you try. This is a conjunction and statement. Push pause and try. Okay, solve the equation, and then when I graphed it, you see that x is greater than -3, goes all the way this way, x is less than 4, and what I did in red is where they overlapped. So that is your answer, just where they overlap, because it's a conjunction, so it has to satisfy both x is greater than or equal to 3 and x is less than 4. Okay, right here I circled that and statement. It's actually not written right. It's -3 less than or equal to x less than 4. It's the correct way to write it, an and statement. Okay, put them together. Solve and graph. You try it. Right, I solved this one. Got x is less than 17, which I've graphed in orange, and x is less than or equal to 2, which I've graphed in green. Remember, a disjunction means that your answer has to satisfy one or the other, not both. So it satisfies one or the other. So your answer is actually, I'll do it in red, the number line less than 17, just less than, open dot. Okay? If it were an and statement, it would just be less than 2, just where they overlap, but it's an or statement, so it's one or the other. And you would only circle this as part of your answer. Okay, you don't have to write that one down, because this graph is described by that inequality. Alright, here you try. Push pause and go ahead and solve. Alright, here you go. It's an and statement, so the solution is just where they overlap, which is done in red, and that's how your inequality is written. I'm going to go back 2 slides and change something that I just realized was circled wrong, so follow along. Alright, remember, the absolute value of any number is x, written with 2 bars on it. X is the distance from 0 on the number line, so the actual absolute value of -5 is 5, and the absolute value of 5 is 5. And if it were on a number line, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, this is your distance from -5 to 0, your distance from 0 to 5. Distance is always positive, and that's your definition of absolute value. So absolute value of equations and inequalities can be represented by compound statements. So for instance, x equals 3. X equals 3 is actually x equals -3 or x equals 3. It's a compound statement or a disjunction. So absolute value of x equals 3. The absolute value of x, like what's in here, can be either -3 or +3. Absolute value inequalities, The solutions are the points that are less than 3 units from 0. So the solutions are everything inside here, okay, not including -3 and +3. So this is actually, absolute value x less than 3. Okay, it goes from -3 to +3. I'll say it again, the points that are less than 3 units from 0. The solution is a conjunction or an and statement. -3 less than x less than 3. A conjunction, which is an and statement. Absolute value of x is greater than 3. The solutions are the points that are more than 3 units from 0. The solution is a disjunction. So it's actually this way. This is absolute value of x greater than 3. And when you would write x is less than or equal, nope, x is less than 3, or x is greater than 3. Okay, reminders. When you're doing greater, this is greater. It's a disjunction. It's an or statement, greater. So it's easy to remember. If it's greater than or equal to, greater. It's a disjunction. Less than, just a little easy way to remember it, less than is a conjunction or an and. Okay, as a summary, you might want to write this down. The absolute value of x equals a. When you go to solve it, you'd set up two equations, x equals -a or x equals a. These absolute value signs should not be here. And we'll go through some examples. Absolute value of x is less than a, less than, it's an and statement. You set up two equations, x is greater than -a and x is less than a, which becomes an answer like this. Absolute value of x is greater than a, greater. Set up a disjunction. X is less than -a or x is greater than a. And as a reminder, I can change my less than and greater than to less than or equal to or greater than or equal to. Okay, let's try an example. Solve. These are equalities we're solving. The absolute value bars are already by themselves on the left-hand side of the equal sign, so we set up two equations. -3 plus k is equal to 10, or -3 plus k is equal to -10. Okay, that's what we learned before. Absolute value of x equals a, which means x equals a, or x equals -a. That's what we just did here. Now solve for k. +3 plus 3, k equals 13. +3 plus 3, k equals -7. And that is our answer. Next, solve. Okay, let's get our absolute value by itself first before we set up our disjunction. +6 plus 6. Absolute value x over 4 equals 4. Now we can set up our disjunction. X over 4 equals 4, or x over 4 equals -4. Solve for x. Times 4 times 4, x equals 16. Times 4 times 4, x equals -16. Okay, you try this one. There you go. Okay, you try this one. Get the absolute value by itself first. There you go. Okay, let's try our next example. It's the absolute values with inequalities. And here's some steps for you. We're going to isolate the absolute value expression if necessary. And this is the first example, it's not necessary. Then we're going to rewrite the absolute value expression as a compound inequality and solve them separately. So let's try this first one. It's already isolated, so I'm going to rewrite it. Negative 4q plus 2 greater than or equal to 10. This is a great or, so I'm going to use an or statement. And negative 4q plus 2 is less than or equal to negative 10. Okay, those are the rules that we came up with a few slides earlier. Solve negative 4 greater q greater than or equal to 8. Divide by a negative and yes, flip your inequality. I did not flip my inequality. Luckily I have an eraser. Q is less than or equal to negative 2. Let's go over here. Subtract 2, subtract 2. Negative 12, divide by a negative. Q is greater than or equal to positive 3. Okay, graph it. Negative 2, negative 1, 0, 1, 2, 3. Close dot at 2. Going to the left. Close dot at 3. Going to the right. And there are my answers. Okay, let's try another one. Remember, your first step is to isolate the absolute value, so I'm going to add 3 to both sides. Okay, this is a great or, so I'm going to set up an or statement. 0.5r is greater than or equal to 0, or 0.5r is less than or equal to 0. Solve for r. R is greater than or equal to 0, or solve for r. R is less than or equal to 0. Okay, graph it. R is greater than 0, close dot, going this way. R is less than or equal to 0, close dot, going that way. The whole number line is actually your answer. So the way that you could actually write this is that way, or that way. Okay, you try. Push pause and try it. Okay. I have the inequality answer and your graph. It's going that way, it's going that way. Last, you try it. Alright, when you go to graph this one, your answer and your inequalities are x is greater than negative 8 or x is less than negative 8. And when you go to graph this one, they overlap each other. And if you remember an or statement, they have to satisfy one equation or the other. So your answer is actually the entire number line, which is negative infinity to infinity. Last example, example 4, we're solving and graphing. I'll go through this one. Like we said, the first one is to get the inequality by itself, so I'm going to multiply both sides by 3. That gets rid of that. 2x plus 7 less than or equal to 3. Less than is the and statement, so we need to set up our and. We get 2x plus 7 less than or equal to 3, and 2x plus 7 greater than or equal to negative 3. Solve away. 2x is less than or equal to negative 4. X is less than or equal to negative 2. And 2x greater than or equal to negative 10. X is greater than or equal to negative 5. Okay, graph it. Negative 2, nope. Try that again. Negative 6, 5, 4, 3, 2, 1. We're going negative 2, close dot this way. Negative 5, close dot this way. Your answer is actually where they overlap. in red. And remember to write it. You do negative 5x, negative 2. Okay, everything in red is your answer. Let's try another one. Multiply both sides by this fraction, because I need to get that by itself. So the reciprocal, we'll get rid of it. Plus, and I just multiplied by a negative, so you got it. Change your inequality. Negative 6. Now set up your, it's now a less than, so set up your conjunction. And make sense? Go ahead and solve. Add 2, p is less than or equal to 4, and p is greater than or equal to, sorry, that's a plus, 8. Graph it. 1, 2, 3, 4, 5, 6, 7, 8. Close dot, less than, close dot, greater than. We seem to have an issue. What do we do now? Okay, we know that with compound conjunctions, your solution has to satisfy this and this, but our graphs don't overlap at all. So I have no solutions that are going to satisfy this and this. So our actual answer is empty set. This is what you would write, and that is what you would graph. Let's try. This is actually you try. Push pause and try it on your own. All right, there you go. Last you try example. Okay, here we go. Our answer and our graphs, and you see that it's an and statement, but nothing overlaps, so our solution is actually empty set, no solution. Good job. I will see you guys tomorrow.